and also connected to the mushroom. So it is connected to the mushroom.
So how does it work?
Oh, okay, so you just take a sip and then I'll kickstart the conversation. And then you can prompt, take a seat there. I'll sit here so that I can. Okay. Hi everyone. We'll just start. I think people are late because of the rain. So we'll just start first, and as people stream in, I think we'll just have people come in every now and then. But thank you so much for joining us at Wild Conversations today. Sorry, let me just pull out my script. So what is Wild Conversations? I think a lot of you, it is actually, if you're new to us, it's actually a casual conversation, usually over food and drinks, and also we discuss issues about nature, sustainability, wildlife, and what have you. And we do always invite an expert to come and speak with us to find out more about the topic. So thank you very much, Amy, for joining us today. We'd like to thank our venue partner, Strangers Lounge, Strangers Conversation. So maybe I'll let Jen, who's seated at the back, tell you guys a little bit more about this space to introduce you, to this space.
Welcome everybody to the Stranger Space at Closer Terrace, and Stranger Conversations host this space, which is like a third place. It's a space for events, it's a space for focus work, it's a space to kind of like bring your ideas to life. We try to be as low barrier to entry for whatever new things you want to start, things that you might not be able to do usually, where you usually are in your first or second phase, which is like home or your phase of business. So this is the third phase for you to explore and imagine. And thank you all space for like having conversations with us all the way from like our very first lounge and then our second lounge. This is our third lounge. We have a second prototype launch somewhere else in the building. So thank you for always supporting us.
Yeah, thanks Jen. Yeah, so it's a beautiful space. They operate throughout the week as well. So if you'd like to come, you feel free to pop by, and there will be people here to welcome you to the space and make you feel welcome. So I also like to thank our videographer, Wei Yang, and Clarice for taking photographs. So if you don't want to be in any of our photos, please let us know. And also do tag us if you do take photos at _wildspace. So while this event is a free to attend event, we strive to keep it free for everyone. We do try to raise awareness for other organizations. And today Amy has chosen to support Nature Society Singapore. So I think most of you, if you don't know what Nature Society is, founded in 1954 and is a non-profit volunteer-based organization that inspires and enables people to take action towards a sustainable and biodiverse planet through engagement, education, advocacy, and research. Amy is also part of NSS, so if you'd like to find out more about NSS, you can speak to her after the conversation. We also strive to keep Wild Conversations free for everyone to attend. So if you have enjoyed the session and want to keep it going, you can also make a contribution to us. The QR code is up on the revolving slides, and I do have a slip to pass around. So maybe I'll just kind of like pass it around to, thank you. Thanks. Okay, so let's start with the introduction of our speaker, Amy. She is a senior lecturer at the Department of Biological Sciences from NUS Singapore, teaching fungal biology, comparative botany, tropical horticulture, and the natural heritage of Singapore. So before I start, I usually like to start off with a quiz to see how much the audience knows about the particular topic. And so today, I guess the first question is, and this is very casual, so if you know, you just like raise your hand and shout out the answer. What is the top 5 most commonly consumed mushrooms in the world? Shiitake? Sorry? Button? Yeah. Portobello. Yeah. One more.
Shimeji.
No. Oyster mushrooms. And the other one's actually the other type of button mushroom. So actually there are 2 types of button mushrooms. The white one is actually the most widely consumed mushroom in the world, the white button mushroom. And then the other one is the brown button mushroom, also called cremini mushrooms. I think that's the other very popular one. Okay, the others are not a question, but actually I realized that there are so many jokes about mushrooms, right? So this is to test your knowledge about, I guess, how many jokes you know about mushrooms. Okay, let's go. So why is there always a party when you have mushrooms? Yeah, because they're fungi. Yes, that's right. Okay, very good. What kind of vehicle does a mushroom drive? Any good guesses?
Okay.
No, but not bad.
Helicopter.
No, not a helicopter. It is a sports car. Such a bad joke, sorry. Okay, why was the mushroom always invited to the kitchen? Because he's a champion. Champignon mushrooms. Okay, mushrooms always win arguments because they don't leave much room for a debate. So bad. Okay, last one. Okay, what is a mushroom that makes music? It is a decomposer. Sorry, bad jokes, but really good. I really had a good time looking at all these jokes, so we enjoyed them. Okay, so I think we'll start off with our conversation now. I guess we do. I think Amy has prepared a bit of a presentation for us as well. But maybe I'll kickstart by asking Amy how she started off her journey in fungi and in like learning about mushrooms. Yeah, go for it. Yeah, this is a mic. Yeah, because it's live streaming. So
okay.
Yeah.
Okay, when I was an undergrad, I had this German professor who took very, very nice pictures of mushrooms. And then during the class, all of us were like, ooh, jaw dropping and everything. And then when we went walking one day after class, we saw this puffball, right? And then we said to each other, 5 of us, this looked like the one that Prof. Ingo Noos shared with us. So we took the mushroom, went back to the lab. Okay, last time there's no lab safety. So we go and cut it up, put soy sauce and pepper, and then we put into the microwave. That used to do the agarose gel and all that. And then we shake each other's hand and say, nice to know you. And then we cook it and then we ate it.
Oh, still alive. So
yeah, still alive. Yeah, so then after that, I wanted to do my final year project with him, but then he said his contract not renewed. So that was like a stop to my mushroom journey. And then after many jobs and all that, I came back to NUS. And then I realized no one is teaching mycology. So I started off with getting an honor student to do the project first. Then after that, I decided to teach it. So I've been teaching this course since 2016.
Okay, so not too long ago.
Yeah, not too long ago. So I still have a lot to learn. Yeah. But from what I learn and ask people, ask questions, and from all my students' projects and all that, we gain more and more knowledge. And we are applying fungi to new things like breaking down the oil spill, the June oil spill.
Okay.
Yeah.
Can you tell us more about that? I'm jumping the gun, but yeah, maybe.
So basically, we try with 2 mushrooms, and then in June I collected the oil spill with the sand and everything, and then we put it on agar, and then the student had to after like 5 weeks and after 10 weeks look at what had changed, right? So she found that for some of the very large molecules that crude oil has actually either disappeared or the molecules have become shorter. which is a good thing, right? Because when it's very big, it's very hard for organisms to break it down. And mushrooms have the ability to deal with lignin, which is what makes wood, right? Very hard. This lignin, right? Lignin is a very, very complicated molecule with a lot of side chains that kind of resemble crude oil. So if the mushroom can break down lignin, it can break down crude oil.
So was it very successful in doing so, and how do you then deploy that?
So we can't deploy yet because it was only a one SEM project. So I need to find another student to continue.
I see. So
But I know it
research?
works. I know it works.
Okay.
It's just that when we scale it up, how are we going to apply it in Singapore's context? Because other people have done it, and then they basically just collected the oil with the soil and everything, and then they just throw in mushroom spores and cover it up. Then after a few weeks, then no more.
Wow, that's incredible. Wow.
Sorry, I thought this NTU and NUS got the seed funding for professors or students to come up with some scalable idea.
Yeah.
To scale it, find an industrial partner and then scale it to a commercial level.
Yeah, but then you can't really commercialize it without basic data, right? And then I don't know how willing people are in eating mushrooms that grew from crude oil. Yeah.
I see. So they do, after you put the spores, they do then grow.
We didn't
But
work
edible.
with spores, we used mycelia.
Okay,
Yeah.
okay, I see. Okay, so maybe, so this conversation is please ask questions as and when you have questions. It's quite free flowing. Maybe we can start by, if you don't have any questions now, we can start by what is fungi, what is a mushroom, and what is the difference. I think that's what we came to find out today. I will jump to your slides so that it helps. Yeah.
Okay, so
Yeah.
can I control? Or
Oh,
no?
can, yes.
Yeah. Okay. Do I need this? No need, huh?
Yeah, you just explained it, but also can. Yeah, so a little bit of background about Amy.
Yeah, so I teach various courses at NUS. Yeah, so okay, skip. Okay, so just some word origin, mushrooms. The term we use it so often, right? But where does it come from? Actually, got all kinds of possible origins. Yeah, so you got Latin, you got French, you got then you got Welsh, you got other Latin. So all these names actually gives you some idea about mushroom. Mushroom tend to be found in wet environment, so near mosses where mosses like to grow. And then some mushroom attract flies. That's why you got the French fly there. And then there's a particular mushroom called fly agaric. So yeah, it's probably referring that. And then some mushrooms grow on the field, right? That's why you got the Welsh origin. And then some are slimy. That's why you got that, yeah. And then the Greek for mushroom is myces. So that's why we get the study of mushroom called mycology. And then the term mycelium, mycelia. Mycelia is the plural term of mycelium. Later I'll explain what is mycelium, mycelia. Yeah, so when we talk about mushroom, usually we are referring to something that we can see, and it's usually quite fleshy, and then it's above the substrates. The substrate can be the ground, can be the wood, can be anything, can be your bread, right? Yeah, so it's basically referring to the reproductive body of the fungus or the mushroom, right? Usually referring to edible, but some of the very, very toxic ones, they look very similar to edible ones. Yeah. Now then, fungi or fungi or fungi, okay, got various pronunciations depending on where you come from. Okay, so if you're British inclined, the modern British, they pronounce it as fungi. The older British people pronounce fungi. And then there's fungi.
American, how they pronounce?
American, they pronounce fungi, fungi. Yeah, I think fungi or something. Yeah. Fungi, I think. No, fungi. Yeah. Yeah. Then I pronounce it fungi. So, but it actually refers to the kingdom, the name, right? So, there's animal kingdom, plant kingdom, then there's the fungi kingdom or fungi kingdom, right? So it refers to all the organisms under this kingdom. Yeah. So they are extremely diverse. Various people had said whether there could be 3.8 million species. Some people say 12 million, right? But those with names are about 1.5 million, okay? Because
a large proportion is still not.
Yeah, still not known, not discovered, or haven't been given names. Yeah. So in general, there are those that are one cell, one organism, meaning unicellular or multicellular, right? Multicellular are the ones that we are familiar with, like this one. You know, this mushroom here is done by my current FYP student using food waste, and then you got the pink oyster. Yeah. Then the one over here is the budding of the yeast. You know, you all use yeast to grow, to make your bread or to make beer. So this is the yeast undergoing budding. That means one become two, two become four, you know. So you can see they are like kind of attached to each other. So it's like pimple, you know. You got one, right? The one yeast cell. Then one of the corner will start to enlarge, right? Like you poke and try and squeeze out your pimple kind of thing. and then eventually it will be large enough, and then it will split off, right? Sometimes they don't split off immediately, oops, and then they will kind of remain like the three together. Yeah, sometimes they will just stay, and then after a while they separate. Yeah. So my students actually ask, so wow, everything also have, so how do you determine this is fungi or fungi, right? So the one thing that unify them is they cannot photosynthesize. So they are not plants, right? And the other thing is they have chitin. Chitin, which be the, you know, the insect's body, right, made of chitin. They don't have cellulose. Okay, plants have cellulose, plants can photosynthesize, although not all plants can photosynthesize. Yeah, but so these two unify them. So why I put a bouquet there is to emphasize that fungi are not plants, right? Yeah, but they are very, very successful. They've been around shortly after the earth has cooled enough. Right? They found fossils of fungi. I have, does this video work? Oh, this is the one that need internet. See whether it works.
Oh, okay.
Eh.
I think maybe my laptop, maybe I can try and connect it to the Wi-Fi here.
You try?
Yeah.
So this is a video that, if it works, will show you how some mushrooms release their spores. So this kind of mushroom is, they release their spore like a puff. So all the spores will puff out. They are the same group as, you all would like this, the truffles, right? They are under the same group, but they are very, very different in terms of appearance and in terms of, this is above ground, truffles are below ground. So I'll definitely try to connect. Does it work? Go back.
Oh no.
It's a YouTube, yeah.
Oh, it's a YouTube.
Yeah, you just close this and enlarge. Can you see the smoke that comes out? Though that's not smoke lah, that's the spores being released. Okay, so these basically is like a cup, and then when the spores are ready, they'll be released like a cloud like this. Yeah. Then the next one is you can close this one. The next one is another way that a different mushroom release spores. Okay. Yeah. So this is your typical mushroom with a cap. This is how they release spores. So earlier that one is puff up. This one drop down, right? So why they drop down is because the spores will be ejected from the gill, and then by gravity they come down. Now these air currents is actually made by the mushroom, and it changes the air temperature so that the spores actually rise. Okay, it's not because there's a wind that makes
its own.
Yeah, it creates its own
dynamics.
Yes. Yeah, it actually changes the temperature around it so that there's warm air, and then help to lift the mushroom spores up. Of course, not very hot lah. But then it's enough to lift the spores up. If it just drops straight down, it's not going to travel very far, right? Once it has this air current, then it will travel further. So the whole point of the mushroom releasing spores is to help their progeny to travel further afield, and then Okay, next one.
Do you know how often it releases spores?
So it depends on the mushroom. So once it reaches maturity, like fully expanded and everything, then it will start to produce spores. And then after it has produced all its spores, then it will auto-digest and disappear.
Only one time?
So it's not one time, it's like it will keep producing until it's finished. Then it will auto-digest. Yeah, this is another video.
Oh, sorry, there's an advertisement.
So can enlarge. Got sound or not?
Yes. Oh, I think because it's connected.
Oh, okay, never mind.
Yeah.
Yeah, so spores would be like their seeds, but actually it's not seeds. They are so different from plants, right? But in order to help people understand, usually they call it mushroom seeds. Yeah. So every spore is different. So the gill part, right, is where the spores are released, except for the other one, they shoot up all the spores. So so once they release, then it's dependent on insects or air current. They'll bring the spores around. Yeah. Okay. So then you might wonder, if they produce a lot of spores, how come the planet is not covered with mushroom, right? Yeah. So it's because they get eaten. Right, they get eaten by all sorts of things, and then also may not be at the right condition. So that's why, yeah. So if you want to do your own mushroom art, you can collect the fresh mushroom, those that drop the spores on. Then you remove the stalk, put it on a piece of paper, and then you cover it, cover with a cap, so that it doesn't dry up so quickly. And then also there won't be wind that will blow the spores away. Yeah. So you leave it for maybe a few hours, then you get this spore print, right? So this is the mushroom. It was put flat on a piece of paper, then you drop, right? So you can see the outline of the gills there. Yeah.
These are the spores that have dropped.
Yes. Yeah. So it means they are hundreds and thousands of spores. Okay? So once you have done this, you can put a piece of plastic and seal it off, so that you won't have the spores being blown all over. Yeah. Anyway, in Singapore, don't go around and collect mushroom all the time because you need permit to collect. But you know, if it's like one near your home, yeah, then that's fine. Yeah.
But also if it's dangerous.
Some people are allergic to a lot of spores, right? If it's just one, two, it's fine. Yeah. So that's why if you buy those mushroom kits and then you want to grow mushroom at home, make sure you harvest the mushroom. Don't wait for it to release spores, because if a lot of them release spores, right, some people develop allergies. They might develop like a flu symptom for a short while. Then once the spores are no longer around, then their allergy symptoms disappear. Yeah. But there may be people who might be allergic, so yeah, must respect them and realize that they are organisms and we are also organisms, but we may have different reaction to mushroom. Some people cannot eat mushroom because they don't like the taste, or they may be allergic to mushroom. Yeah.
I think the parents are very worried because the kids will see these things very strange.
Yeah.
So they tend to, some kids tend to take everything and put it in the mouth.
Yeah, that's dangerous. Yeah. Because actually a lot of the wild mushrooms, they tend to be toxic. Most of them that we see, you know, are toxic. Yeah. So yeah, don't put it in your
So
mouth.
I think there was one question that was submitted by someone before. They were asking, how do you know what is edible or what's not? So how do you go about? So firstly, I guess foraging in Singapore is not allowed because you need a permit, so no foraging. But how do you identify an edible or what's poisonous?
With great difficulty. Yeah, even experts can get it wrong because some of them really look very similar, and you definitely need to look at the microscopic structure in order to identify correctly. So if you don't have a microscope, just by visual will be quite hard. Yeah. Okay, next. Yeah. Yeah, so this is under it's a different kind of microscope, so that's why you can see it like this. So if you look closely, the mushroom spore actually is not just one round circle. You can see something inside the circle, one bigger and one smaller, structure. So these can help to identify spores of different mushroom species. And spores are produced, when you have the mushroom, is a sexual reproduction. The asexual reproduction is completely different from this. Yeah. Okay. This is asexual reproduction. So, Chinese New Year, your Mandarin orange always happen, right? You see all the mole. Yeah, so these mole, asexual reproduction. And then this bottom picture here is basically growing on agar. So then the fungus starts from the middle and then they grow outwards. Yeah. Then why is it green and white? White means it's mostly mycelia. Then the green are the spores. Okay, so if there are a lot of spores, means they are more and more green. No?
So they are reproducing.
But asexually. Yeah. So these are all identical. The sexual one, each spore is different genetically. Yeah.
So these are usually mold that we find on fruit and bread and
Yeah.
they're all similar.
Yeah, they are all
similar
asexual
to.
reproduction.
Okay, but are they the similar type of, like, I guess fungi?
Different group.
Oh, different groups.
Yeah, different group altogether. Okay, so once the spore lands on a suitable location, then they'll produce what is called hyphae. So it's like all these strands of hair right? And then if you see, when you go walking in the forest or park, sometimes you see some leaves that have some whitish like threads growing outwards. This is the fungus growing. This is the hyphae growing on the dead leaf. So actually they are very nice, you know, in terms of like art. They look quite nice. Yeah. Okay, next. Now, when we try to culture them, this is a petri dish with agar. So the agar provides the food. So once we can get a bit of the mycelium, the hyphae, right? And then we put it in the center, then it'll grow outwards. That's why you can see it's this round thing, then it's if you can do time lapse, you know that it's spreading outwards. Okay? So basically, the very interesting aspect about fungus is that the hyphae, right, as it grows, it will release enzymes and digest whatever that's outside. Once it's liquid, it will absorb in. Whereas we put the food in us, we digest and then absorb. They digest externally and then absorb. Okay? Yeah.
So does it always become liquid in a liquid form?
Yes.
It always does.
Or close to liquid. Yeah. Yeah. Then they store glycogen like us. We store glycogen. Yeah.
So they are like humans,
In animal.
animal.
Yeah. So you see mushroom ring is because they grow outwards, just like the agar, right? They grow outwards and then when it's suitable, they'll produce the mushroom. And something else fall in the middle and then they will grow like in the center also. Okay, where can you find them? Basically, next, they are everywhere. You're breathing in fungus spores now. It's in the aircon if you don't clean regularly. It's in the soil. Even desert has mushroom, the real thing, you know. Yeah. Yeah, everywhere. They are basically everywhere. So, and it's good that they are everywhere in a way, because they help to break down all the toxic substances and make them useful for us. And for many of our plants that we grow for food, the roots have symbiotic fungi that help the plant. Yeah, so like all the wheat, the barley, the rice, they all have. Okay, it's a different group of fungus. Even your orchid, the young orchid seed basically has almost no nutrient, no storage food. So it relies on a fungus infecting the seed and then provide the seed with food. Then the orchid will grow.
Oh, so otherwise the orchid cannot grow
Yeah.
without that.
Yeah.
Oh, okay.
Yeah, same with some ferns. Yeah.
Look at the fungi survive all the 4 seasons.
Yeah, they can. So if they are, if you find the same one all over the world, that means they can survive all kinds of temperature. Yeah.
And you mentioned desert, right? Doesn't fungi usually require like moist conditions?
So if they are in the desert, they will be below the sands, near the oasis or anywhere there's some trace of water. Then when it's suitable, then they will produce the actual mushroom again, above ground. Yeah. Yeah. So then this is quite recent, where there's no video here. Yeah. So this one, they actually found a mushroom, right? A typical mushroom in a very clear cold water in the US, Yosemite actually. Yeah. So this was a first, because last time we all thought that this kind of mushroom usually is on terrestrial environment, but this one was actually in the water at the base of the riverbed.
So which means that it's inundated.
Yeah. And it's producing spores, and then the spores will follow the river. Yeah.
Oh.
And subsequently, they found the same mushroom on the shores also.
So this is the first of its type.
Yeah.
Interesting.
Yeah, then at home, if you leave anything organic lying around, then you get them moldy. So basically, the spores are everywhere. So if they land on a suitable food type, they will start to grow and then produce spores. So this one was Chinese New Year pineapple cookie. Oh, so sad.
Was it yours?
Yes, yes. Yeah. Okay. Yeah. Then this one was my class. I give them the petri dish, and then they choose wherever they want to go on campus. Some even bring home, and then expose the agar to their home environment or in campus. And then after a while, they bring back. Then 2 weeks later, you see all kinds of things growing on the agar. Yeah. Now, even, I don't know whether you all have used, those glass slides in schools before. And then you look under microscope. So if you look at glass slides, if you haven't used them for a while, if you put the glass slide against light, right, you will see some, a bit blur. You see some lines. Yeah, basically the fungus is growing on the glass slide. Okay? It can be brand new, unused glass slide.
So how does that happen?
Okay, so what happened is, as I told you, the spores are everywhere, right? So even in the production of all these glass slides, there are spores, right? So they'll land on the glass slide. And then the fungus will utilize the nitrogen in the air for its nitrogen source of food. It will produce hydrofluoric acid. You know hydrochloric acid, right? The other one is HF, okay? In our modern living, HF is used to etch, computer chip, right? So it is an extremely powerful acid. Now, if we were to handle HF with our bare hands, it will dissolve our bone. Okay? So these fungi are basically eating into the glass to get their food source. Silica lah. Glass is basically silica. Yeah. So this was actively growing on the brand new glass slide, and I took a picture.
Oh.
It's kind of nice, right? The way it grows.
Like a snowflake, almost. So if you leave it long enough,
It'll grow. It will cover the whole slide. And then because of the acid, right, you can't use the glass anymore because it will be very uneven.
because it's eating through.
Yeah, it's eating through the glass. Then in this picture here, right, these kind of mushrooms are very soft, right? The cap ones. And yet, this actually push the asphalt up. Okay, the asphalt actually was flat before, and then it pushed them up, and then it emerged. So mushroom with the mycelia are actually extremely powerful because of their turgor pressure. Basically, it's like water. Under very, very high pressure, it can push through a lot of things. So this one, it pushed the asphalt up, and then emerge, and then open up the cap. Yeah. So that's why you can see wood being broken down because they push through the wood, right? They can break down those wooden houses because they are pushing through the wood in the wooden house.
So how do they kind of, so which means that it actually needs to be quite a clean environment in order for them to build these things, because otherwise it's like trapping the spores underneath and allowing it to grow? Or
What do you mean?
how does this happen? Because it happens in some places and not all, right? So like you mentioned for this particular case for the glass, it's because there are spores everywhere, and then it just so happened that maybe during the production it happened. So is this the same case?
Yeah. So in this particular environment, probably there were some plant material beneath, right? So the spores landed there, then they grow, and then after that they have to emerge. So then they push the asphalt up. Yeah. So they must have water, they must have food source, or they create their own food source. They eat whatever they can digest. Yeah. Yeah. So then, okay, the challenge of studying mushroom is that after they release spores, right, just now you were asking, they will auto-digest. Basically, they will break itself down and liquefy and disappear. So that's why now you see me, now you don't, kind of thing. You know, today you see the mushroom, then you come back a few days later, no sign. Yeah. So it's not like plant will be there, right? But yeah, this one difficult.
Do all mushrooms undergo this process?
Close to, yes. Yeah. It's how fast they auto-digest and liquefy. Yeah. Yeah, so this one is another wild mushroom that you can find in Singapore. This one is callistemon. Okay.
This is similar to, yeah.
No, you mentioned that in 2016 you found an honor student to do this mushroom, right?
Yeah.
So today, now 8 years down the road, how interesting is this mushroom? Are there many students taking it up?
Every year it varies. So now I have about 30 plus students in my class. Yeah. So it varies. It varies from 8 to 10s and 20s and 30s. I don't know this coming semester how many I'll have.
Science syllabus from, I mean, they introduce science at primary 3. So from primary 3 onwards, at which level do they learn about?
If they, recently the Ministry of Education realized that they don't cover much biodiversity, so they'll change it, and then I think this current year or the last year they already introduced biodiversity in primary school level. Yeah, so they'll learn a bit more. Yep. Okay. Yep. Okay, next. Okay, so which is the world's largest organism?
Living organism?
Yeah, living organism.
Whale.
Okay. Right, but then the honey fungus is actually the world's largest organism. You can actually see it from the air. So why is it called the largest organism? Because when they discovered it, right, they actually do some genetic analysis and realize that this is actually one organism, okay? And it's also very old, right? It's about 8,000 plus years old. And then they estimate the weight is really quite heavy.
When
Yeah.
you say air, actually you mean space.
No lah, this is from an aeroplane or helicopter, I think. Yeah. So all the brown patches is basically the fungus has killed the trees, so it's brown. Yeah.
So how did they realize that it was the same?
They did some
yeah.
genetic analysis.
Oh,
So they collected the fruiting bodies, these mushrooms, and then they analyzed them and realized no matter where they collect, it's the same genetically.
Wow,
Yeah.
crazy.
Okay. So in Singapore, we have, if you go walking around, have you seen them before? Yeah. So common name is like, dead man's fingers, right? But then there are users. So this group is called Xylaria, the scientific name, Xylaria. One of the Xylaria nigripes in Chinese is called Wu Ling Shen, is used in TCM. So I think if you go to Chinese TCM, you ask for Wu Ling Shen, they'll be able to produce it. So it's supposed to treat all these insomnia, trauma, depression. And the same Xylaria, another species, this was a collaboration with another, I think it was a German university. So they get exposed the wood to this fungus, and after a while they use the wood and make violin. Okay, and then they ask people, compare this violin made of fungus wood to Stradivarius violin. Some people can't tell. Yeah, so
they found an alternative.
yeah. Okay. Yeah. Okay. This one have you all seen before? Yeah. So this one can be used to thicken soup, right? The one with the zhusheng, this is commercially produced by the Chinese. They collect the veil part and not the top part, and then they dry it, and then that's what you get, right? So you can put into soups to thicken it. And also it's very good for health because it helps to, you know, if your stomach has inflammation, if your gut microbiota is not so good, yeah, you can take some of these, no harm, right? Yeah, in the wild, when you see it, it's quite smelly. That's why it's yeah, some people say stinghorn, like stinky, very smelly. But then if you like to look at it romantically, then it's bridal veil. Yeah, but it's the same fungus. Yeah. Okay. Yeah, so just now you all were talking about the world's most favorite mushroom is the button. So actually they are the same scientific name wise. Okay, it's just a different strain. Yeah. Yeah, then fungus, sometimes you don't even know you're looking at a fungus because they can form partnership with other organisms. So this is our local lichen. Okay, lichen basically is a fungus with a photosynthetic partner. So it can be in the form of algae or blue-green algae. Blue-green algae is cyanobacteria. Yeah, so depending on what's the partner, then they'll have different growth forms. Okay. Yeah, then sometimes you see while you're walking this lump of thing that look like a seed. Actually, it could be a fungus, right? Ever since I saw this first time round, right? Then when I go walking, then I start to see, you know, then I thought this is a fungus. Then when I move it, then I realize, yeah, it's a seed. Yeah, so this one is called earth ball. So well, I guess it looks earthly and then it looks like a ball. This one is actually mycorrhizal fungus. Mycorrhizal means fungus root. So it's associated with a plant, right? And then basically it's with the plant root, and then ever so often it will come up and form this earth ball. Now then after a while they will split. The top part will split and then they will open up. And then you see, if it collects water, then you see this mass of dark liquid inside. Yeah, otherwise it will just be dry spores. Yep. So they can associate with trees. They can also associate with vanilla orchid. Yeah. Okay, so most of the time you see mushroom, right? But there are also microscopic ones. Okay. So your home, kitchen, shower curtain, bathroom, yeah, all those black stuff is not dirt, it's fungus, it's mold. Okay. Then yeah, aircon, yeah, this one very common. So one time I was undergoing some minor operation and I look up the ceiling on the hospital bed, and then I saw mold. Then it's like, oh no, this is an operating theater. So I told the nurse and the doctor, but then they don't seem to care, right? They don't know it can be dangerous. Yeah.
So not so good to know too many things.
Well, I always say ignorance is not bliss. Eventually the truth will catch up with you. Yeah, so this is the yeast, right? So, can you get alcoholic bread? Why not? Yeah, when you heat, right, when you bake, the ethanol will vaporize. Yeah. So you can add your alcohol later. Yeah. So I inherited a bread maker. So when I got it, I was so excited. I go and buy organic flour, organic raisin, organic yeast and everything, and then put everything in the bread maker. And then when it started to heat, the whole house turned black.
Oh dear.
It tripped. The bread maker, because it was a bit old, so it tripped. So, cannot.
So there was no bread.
So no bread. Then had to just cook it, then become very very hard. Yeah. So without the yeast, right? Utilizing the sugars and then producing carbon dioxide, your bread won't rise. And because if it doesn't rise, then it will be solid, very, very hard. Yeah. Yeah, then, is yeast cause the bread to rise, make beer. Some people have yeast in their gut. So any carbohydrate that they eat, the yeast will convert into alcohol. So it's not a good thing because you're constantly drunk and not because you drink alcohol, right? So this is a rare condition, but it does happen, and this is a local case. The first time I encountered this case was in the US. Yeah, so this guy was quite poor thing.
So so it's genetic.
It's not genetic, it's some gut imbalance. So he happened to have a lot of yeast in his gut. So to solve this problem, he had to take a lot of antifungal pills to get rid of the yeast. Yeah.
And it's a lifelong condition? Or?
No, you can recover from it. Yeah. But must first know that this is the yeast. Yeah. Yes. Now, it can happen to any one of us too. If you, especially now with climate change, it's very humid, right? So we can get fungal infection on our toes, on our fingers, on our skin. So when you start to see your toenail don't look normal, look turning powdery, then you probably got a fungal infection. Yeah. So go and see a doctor or go and buy those toe fungal.
Powder.
No, it's not a powder. It comes in a drop. Then you have to keep applying until your toe recover. Then in the meantime, keep your shoes and your socks clean, and then because it can infect other people living in the same household. Yeah. Okay. So this is another kind of fungus. Just now I mentioned the mycorrhizal kind. So this one is microscopic. You will never see it producing a mushroom, right? The picture here with this a bit brownish, these are the spores. So if you dig up some plants like wheat, like rice, when you pull up the roots and then you look under the microscope, you might see the spores on the root. Now this is the arbuscular mycorrhizal fungal spores. Now these fungus, right, it go into the plant roots, and then the other end is traveling the soil and getting nutrients. So it will bring phosphates and nitrates, go into the hyphae, then pass to the root. So it's like an extension of the root, but it's not part of the plant, but it helps to bring nutrients to the plants. So earlier I was at the conference, and then there was this French company selling the spores, right? So I asked him, what do you have? Then this company go around the world and collect the spores from the country, and then they mass produce, then they sell it back to the country. in other locations, even in Singapore, you can order these arbuscular mycorrhizal fungal spores and then you grow them in Singapore. Now, this is not a good practice because when you order from, let's say, Amazon or Taobao or whatever, you're bringing in a foreign spore which could outcompete the local diversity. So try not to do this. Okay, because already we are bringing in foreign plants, foreign animals, so don't bring in foreign fungi. Yeah, although many of the organic farms are advocating this, in theory is good, but as long as they must be produced locally, right? Don't buy those that are found overseas and bring them in. Yeah.
Are there local producers?
Yeah, we have local ones, but we haven't got to the state where they mass produce and sell. We're learning, yeah. Yeah, so this kind of fungi are very, very good because they help the plants to not only get the nutrients, but also help the plants to cope with external stressors like warmer temperature, drier condition, heavy metals in the environment, salt, right, seawater rise encroaching into the soil. Yeah, so they are very, very valuable and very important. But you never see them. You never heard of them before today. Yep.
Yeah, interesting. So they help the plants to cope with climate change, changes in climatic conditions. How do they
of course, there's a limit, right?
okay. It increases the adaptability of the plant.
Yeah, sometimes when you buy fungus, even the commercial ones, you find that they taste a bit weird or they are very, very smelly. Right? I once bought those black fungus. When I opened it, the smell was terrible. So they have been affected by other parasitic fungus. So in this case, this is the oyster, right? But then the white part are those parasitic fungus. So in the wild, not only do they auto-digest and disappear, then there are other fungus that will attack the other fungus, right? So yeah, they'll kill them too.
So it actually makes it poisonous, something non-poisonous, right? Because
Probably, yeah. Usually we don't eat the parasitic ones, right? Yeah. Can you open this? So in the water, in the aquatic environment, there are also fungus. Most of the time we don't know where they come from. Usually they are microscopic, so it will just play, right? The spores are very interesting, very weird. It takes a while. Yeah. Then they produce microscopic fruiting bodies, and then these are the spores. Yeah, so like this. So they look completely different to what we are familiar with.
But you cannot see them.
With your eyes, you can't see them. You need microscope. Yeah. Yeah, so far I haven't ventured into aquatic fungi yet.
That's a whole different field.
Yes. Yeah, so there's dead wood in the water and all that, right? So it's because of these microscopic aquatic fungi that will break down the wood. Otherwise, they'll still be around. Then in the gut, in the cows, in the goats, there are also fungi that help them break down the plant material. In our gut also there are fungi, but not as many. So that's why we cannot survive completely on cellulose plant material. Yeah. Then also fungi work with the microscopic fungi with plants, right, which I mentioned earlier. Then there are also the macro fungi that work with plants. Yeah. So why are they important? Well, there's the partnership with plants. And then, you know, most of the time when people talk about carbon sequestration, they only look at above ground. They look at the plants, they look at the wood. But actually, in the soil, there's a lot of fungi. The hyphae are basically carbon, right? So there's a lot of carbon in the soil because of fungi. And the arbuscular mycorrhizal fungi, the one that is microscopic, you see only the spores, they actually produce this substance called glomalin. Basically, it's like a glue with some protein, with a lot of carbohydrates, and these glue-like substance, they help to bind soil particles together, and they help reduce soil erosion, you know, or soil particles being blown away or washed by the water. So they are very, very good to have, right? When the environment is healthy with a lot of fungi in the soil, you store a lot of carbon, you bind the soil particles together, you prevent erosion, and they also support plant growth. So it's a good thing.
How do you identify if a soil has a lot of glomalin?
Usually the whole forest is intact with a lot of plant species that you know form these partnership with the AMF. Yeah, monocots are mainly monocots. Grass, grass fields next to a forest, you can get a very good ecosystem. So this is a project done by a mycologist friend in Thailand. So, you know, we talk about reforestation, we talk about, you know, the 1 million tree planting project, right? Very often we just grow the plants. Now, if you're a country with poor people, you ask the poor people, hey, you know, plant these trees. 30 years later, you can cut down the tree and get money. They are going to look at you, what am I going to survive on in the meantime, right? So this project is the mycologists introduced this fungus, which is called estrius, which is all these round thing. So this estrius form a relationship with these trees, and these trees are dipterocarp. You all know dipterocarp? The garrowing and all that, right? The very, very good timber, shoria and all that. So this one is dipterocarpus. So the trees are growing, right? And then the mushroom will come out every so often. And then the Thais, they eat this mushroom. So the farmer can harvest the mushroom and sell and gain money, you know, have a livelihood while waiting for the tree to grow.
So they have like a symbiotic.
Yeah, symbiotic.
Okay.
Yeah. Yeah, then what's so important about having fungi rotting wood, right? Sometimes if you are a forester, you want your tree, right? You don't want wood rotting. But then if you look at it in an ecosystem level, if there are no fungi, the dead trees will be around. And this is an actual case during the Chernobyl nuclear reactor accident. The radiation spread so far and wide. So everything was killed. Bacteria, fungi, plants, animals. So the dead things remain intact for a few decades. Right? Until later when the wind bring the spores, bring the bacteria back, then slowly decomposition start. But in the zone, the red zone closest to where the reactor was, it's still very, very slow. Decomposition was still very, very slow. Right? So, yeah. So without decomposition, actually is not a good thing because all the nutrients will be locked in the dead organism. Imagine all of us remain dead and unrotten. Wow. Your dead pet will still be alive, looking alive. It's not a good thing. Yeah. Then there's this company called Koyo or something. Yeah. So I guess they are mycologists. So they invented this mushroom suit, right? Basically, when the dead person dies, they wrap this suit, which has fungi, spores, mycelia, everything incorporated. And then after wrapping the dead body with this suit, it will still be buried, but then it will be decomposed, right? So it's a more natural kind of way of, decomposing the dead rather than cremation. Yeah. Then if you go walking around at night in the forest, you might see bioluminescent mushroom, right? So they are producing these lights. When your eyes are adjusted, right, to the dark, you can see it. Basically, they are there all the time. If they are producing light, daytime they are also producing light. It's just that nighttime, then we see the light.
How do they produce light, and what gives them that?
So it's very similar as firefly, okay, but its molecular structure is a bit different, but it's the same similar mechanism lah. It's luciferin, but the luciferin is slightly different from in the case of fungi. And then up till now, no consensus as to why produce light, because there are some mushrooms that produce light all the way with the cap, with the stalk, others just the stalk, yet others just the mycelium. So yeah, no idea why. Yeah.
Do you know how many species are there
A few hundred
that
can do this. In Singapore, we have three different species that can produce light. Yeah. So me and Serena, we and another two friends, we went looking. Yeah. So we saw them.
Wow.
Then because Serena is NPark staff, right? So we don't need permit. And then she put it in the bag, and then we were following behind her, and when we can see the mushroom glowing through the bag, it was so bright.
Wow.
Yeah.
Incredible.
And then it was still glowing until the next morning. It stopped glowing when it dried up. Okay, if it were still alive, it will still be glowing. Yep. So in terms of daily living, okay, we can get a lot of good things out of fungi. You can get biofuel. Biofuel is ethanol. The paper and pulp industry uses a lot of acids to make the pulp, right? To make the paper. So people have tried using fungi, the enzymes produced by fungi, to soften the wood to make into paper, to remove the lignin part. Then in terms of waste management, it can also be used to break down waste material. You can also get fungi to be an animal feed. Some brands of laundry detergent actually have the fungal cellulase so that they can clean your dirty clothes better. The ripped jeans, ripped jeans with all the holes. It's not somebody go and use scissors and cut. They apply the cellulase from the fungi, and then you get your ripped jeans. There's another group called the stone wash jeans, right? So in the past, it's really stone, right? But in more recent times, there will still be some people using the stone, but there'll be other people that use the cellulase. Yeah. Then your wine and beverage, the cellulase actually make the wine clear, the more not so cloudy. Yeah. So there are some such applications as well. So we are using the cellulase from fungi and other applications without knowing. Yeah. Ta-da, your cheese, right? You have fungi to thank also. So these are the microscopic fungi, the asexual reproduction that help the milk to become cheese. Yeah.
And these are obviously edible.
Yes, yes, yes.
The blue cheese one.
Yes. Yeah, then if you like to eat mushroom and you eat it regularly, actually it helps to reduce mild cognitive decline. Yeah, so eat mushroom regularly.
It has a lot of B12 apparently, right? They say vegetarians should take.
Yeah. And some of the mushrooms that's been exposed to UV actually have vitamin D, but not all. Okay, but there are a lot of minerals. There's zero fat, so you can't grow fat eating mushroom. Yeah, and then help, very, very helpful. Your cognitive ability is strengthened, your immunity is strengthened. Yeah.
So actually, there was a question by someone because you mentioned that if it's exposed to UV, then it takes in the vitamin D. So
it makes the vitamin
it makes the vitamin D. Okay.
Yeah.
Someone asked. I understand that mushrooms from roadside absorb harmful toxins. So if you made a clone from that mushroom, would that clone also make toxins? Also contain toxins, or could it be? Yeah. Oh, okay. Yeah. So I thought. It's
I'll
similar.
explain later. Yeah, so tempeh. So tempeh, is soybean with the fungus. This one is another asexual fungus. So it will grow and incorporate into the whole thing, binding the soybean together. Then after that, you kill the fungus, and then you can steam, you can fry, and then you get your tempeh. Yeah, also very, very healthy. Yeah, so eat. Then, fungus fashion. I don't know whether it works. Is
So tempeh is actually the mycelia that you're eating, is it?
and the soybean.
So whole fungi.
Yeah.
Oh wow.
Somebody sent me this.
It's made out of. It's
I think it's just,
not made out of.
no. It's just designed based on mushroom.
But they did. There was
Yeah.
that uses mushrooms to make like
Yeah.
fabric.
Yes. So that one is Ganoderma. Ganoderma, there are different, many species. The Ganoderma lucidum is the 灵芝 or reishi. Yeah. So earlier there was a question about fungi taking in toxins, right? So just now I mentioned the fungus as it grows, right? It breaks things down outside and then absorb in. Now heavy metal is a metal, right? So it cannot break anymore, right? So the fungus will absorb it in, right? It will simplify until it's in a liquid state, then it will absorb it in. So it will clean the environment of the heavy metal, then it will store it in its body. Okay, but it won't be harmed by the heavy metal because they will bind it such that it is not, in general circulation and affecting its physiology. Yeah. So, so if you clone this mushroom, depends on whether the heavy metal has been moved to the new parts, right? If it hasn't, then it's okay, right? Yeah.
Okay.
So spores are the safest lah. You should take spore brain of them. Or can it transfer the spores also?
I don't know. Yeah, I'm not sure. I haven't thought of this before. I can find out. You can drop me an email, let me know. Yeah.
Model student.
Yeah.
Then plastic degradation. So the microfungi can also break down plastics, but a bit slower. So it takes several weeks, and it depends on what kind of plastic. The PE, polyethylene, can be broken down. PP not so fast. Polyurethane even slower, but they can break down. Yeah. Then the persistent organic pollutants like those herbicides that we spray, or those computer stuff that like pipes and hose, and those very very old kind of persistent organic pollutants. So they are persistent because bacteria don't recognize them. Plastics have been around for a long time, bacteria didn't recognize them, so that's why they remain, right? So fungi learn to break them down because like they can break down lignin, they can break them down. Yeah. Then pharmaceutical drugs also got carbon, also got all kinds of endings which the fungi can also break down. Synthetic dyes is a big problem because textile companies, they dye the clothes, right? Very often they have heavy metals. So once they discharge, it goes into the environment and they don't break down, right? So if the fungi had been applied, then they'll help to take in the heavy metals.
So are we saying that actually fungi is a good kind of solution for a lot of, for example, like because plastic is a big problem now, right? And it takes a long time to break down. I mean, a few weeks is actually, it sounds a lot better than taking. Yes, exactly. Yeah. So why is it not used more widely than in I don't know, in the industry?
Who's gonna pay?
Oh, so is it?
Yeah.
Expensive?
Yeah, I mean, in a way, yes, because first you have to collect the plastics, then after that you have to let the mushroom break it down, then there's nothing to sell, right? So you can't, it's not a business case. Unless you can make a product, then you can sell, then it's worth it lah.
I see.
Yeah. So even micro-remediation, right? You can't really make a lot of money out of it unless that land is very, very important. Government want to pay, and you can do it fairly fast, fairly quickly, right? Like the oil spill, for instance. Government will want to get rid of it ASAP because it affects businesses, right? You can't, the hotels, the beach goers, yeah. So unless they are collected and removed from that location, and then you give the fungus time to break them down, otherwise it's not money making.
Right. So
Yeah.
it has to have an economic case for it to be deployed.
Yes.
So it is actually considerably more expensive.
Yeah, unless the plastic that's been broken down, you can get something out of it that you can sell. Maybe grow mushroom. I don't know. Yeah.
That'll be more expensive than truffle.
Yeah, so just now there was a question about mushroom foraging in Singapore. Okay, first, there's not much to forage. Okay, it's not like temperate countries where they have seasons where there's a lot of mushrooms of the same type. We don't have. Okay, when they do produce mushrooms, is like maybe one person collect and that's it, gone already, finish, right? So it's not worth it. And because we have so little parks and so little forests left, and if everybody go into the forest to do mushroom foraging, first, not many to collect. Next is the feet trampling on the ground, right? When you trample, the mycelia in the ground get compacted, they may die, right? So you're doing more harm than good. And what's more, we don't know enough about local mushroom, right? We are still discovering species. It's not that they are new to science, it's just that we don't know what we have, right? So few people study mushroom. So once we collect, first we have to identify. Next is determine whether they are edible or not. In many of the literature, they just at best give you the name. They don't say, this is edible. No, they don't tell you. So you want to try?
So how do you determine that?
You have to look at literature. And then even then, sometimes people disagree, right? The Swedish will say, this is edible. Then the Germans will say, no, this is not edible. even though it's the same thing. So yeah. Yeah, don't anyhow pluck, right? Yeah. So yeah, so just now mentioned about Chernobyl, right? So during the when Chernobyl happened, right, then several decades later, there are mushrooms growing, right, decomposing the wood. And then the Romania gypsies, they were collecting these wild mushrooms and then selling to French restaurants. Without knowing of course the French, they cook the mushroom, then these people are being poisoned by the radiation. And this was actually reported in one of the newspaper articles. Yeah. Yeah, then also, in pharmaceutical companies, they make medicine that are profitable. So they must be something that people take a lot of, right? Cholesterol, blood thinner, whatever, So there must be a demand. So antifungal drugs, not so useful, not so demanding, because once you clear your fungal infection, that's it, no need already, right? So not many antifungal drugs. So when you go to the pharmacy, you go and look for antifungal creams, there are only a few brands, very few, less than 5, right? Then if you have fungal infection, they are more serious. There are basically very few antifungal drugs. To cure the person of very serious fungal infection is actually quite dangerous, because fungus and human are very similar, right? They have glycogen, we have glycogen. They are eukaryotes, we are eukaryotes. Eukaryotes means not prokaryotes. Prokaryotes are the bacteria. So in killing the fungus, we get sick also. So those people with very serious fungal infection, after the treatment, they may have kidney failure, they may have some liver damage, but at least they survive. Yeah.
So actually a fungal infection is actually quite detrimental.
It can be. So for people who are immunocompromised, a fungal infection can kill them. Yeah, so fungus love water. With the increased humidity, is just gonna be, we're just gonna be host, man. So what can you do, right? Just keep yourself clean, but not too clean, right? Don't keep going to shower 3-4 times, right? Because you need a healthy biodiversity on your skin, so that you can fight against the fungus, potential fungus infection. And then keep yourself healthy, so that you have good blood circulation, no diabetes and stuff. Yeah. So hope you all learned something new about fungi, right? There are loads we don't know, because there are so many millions of species out there. We don't even know what they do. But what we do know, if you ask any mycologist, they'll say fungi are beneficial, right? Even though there may be some that will kill us, but in general, they do so much for us, right? So we need to understand more about fungi. Yeah. And then, so if you're a student in NUS or even NTU, can come and sit in our classes. So I teach fungal biology. Another colleague from biochemistry teaches medical micro and drug discovery. And then if you want to learn about macrofungi, that means the big ones, you can buy this book written by Serena and myself. So it's available at Botanic Gardens or any major bookstore. I think it's $27. I don't know. I think the price has changed. So if you want to buy this year, because next year the price will go up again. And then you can also borrow the book from NLB. And then if you want to buy other books, so this Lynn Brody, this one, this book, Lynn Brody is a mycologist from UK. Is a good book to buy. Then a cheaper one, Entangled Life. This one is very easy reading, but I think there are no pictures. Yeah. So some of the stuff I teach is also mentioned in the book. Yeah, that's it.
Thanks so much for sharing. I think I learned a lot about like fungi and my mushrooms that I eat now. Are there any more questions from the floor? Yes.
Because you were saying that if we're a student, we can attend the classes, but if we're no longer in university, is there anywhere that we can go for like ecology classes?
How can more people learn about mushrooms and fungi?
Unofficially, you can come and sit into my class. Yeah, there are people who ask to sit in. Yeah. But it's during class time. Yeah, for working adults, maybe not so good. Yeah. You can read up, right? You can read up. Just make sure you don't buy AI generated mushroom book. Yes, there are such books now. Sad to say. Any other questions?
Yes.
So, like earlier we said, like fungi are like they can solve many, like break down these pollutants, even waste. But is it like already closed, or will there be another waste or like maybe growth of mushroom we need to deal with after?
Oh, so dealing with.
Okay, so let's say if it's organic, like persistent organic pollutants. So let's say the mushroom break it down, then there'll be carbon dioxide, sugars, that's all. But of course, if it's heavy metal, then it'll be inside the fungus. Yeah, that's all. So there is not like chemical treatment where you start off with using acids to deal with some pollutants. Then after that, there's some other intermediate steps. Then there are some other intermediate steps that you have to deal with. So for fungus, if it can break down, it will break down all the way to very simple molecules. Carbon dioxide, sugars, or incorporated into part of the mushroom. So it's actually very good.
Any other questions?
Like for plastic degradation, is it to the stage of like microplastics?
So it's going to be complete also. Going to be like CO2 and then incorporate into the mushroom.
That takes only a few.
Yeah, a few weeks. Depending on what kind of plastic, yeah, and what kind of fungus.
And for the mushroom, like what happens after they break down?
So if you don't give it any more food, then they will die. Yeah.
How does sexual selection, how does sexual reproduction work for
So let's say in the environment you have a king oyster spore, right? And then you have another king oyster spore, right? So when they become hyphae, then they will meet each other. I always tell my class, when Harry meets Sally, then they will join, the two hyphae will join, and then the nucleus from each will fuse, and then they'll undergo meiosis, and then they'll produce spores. So each time there is a new, in one part there'll be 4 spores, right? So all 4 spores are different. So another part will be another 4 spores, and they'll be completely different. So each one will be a new combination. So in the natural environment or even in your bread, right, you start to see things that come out, the black stuff, that's sexual reproduction. So spore A meets spore B, then they fuse and then they produce, that spore bearing structure, and inside there all the spores are different.
So there's a group of humans who say that, okay, I don't eat plants, no, I don't eat animals, I only eat plants, right? So are there the third group now who say, I don't want to eat plants and animals, I just want to eat fungi, because fungi is more healthy than these two groups?
I think not enough. So far, I don't see people just eating mushroom because I think it's more expensive than eating plants alone. And it's not going to be enough lah. I mean, you need carbohydrates. Mushroom, you have to eat quite a lot to get the carbohydrates. Yeah. And it's more expensive than rice, for instance. And then some vegetarians I heard, they said mushrooms are not vegetarian, right?
Oh, okay.
So they consider it as animal.
Because it's not a plant, right?
Yeah.
More.
Yeah lor. So I was surprised also, but then they said no, they cannot eat mushroom because they are another group of vegetarians.
See, there's some plants that need animal to spread, to reproduce, and so bring the spores together, like bees and all that, right? Whatever fungi. Are there certain animal or certain plant help to bring them together? Like here you say one, the king of meat, another one, right? But is there a facilitation process also taking place?
Okay, so let's say truffles, right? If we never eat truffles, the truffles in the ground will be eaten by animals, pigs, other wild animals, right? There are other truffles lah. So for these, they'll need the animals to eat and then disperse the spores. Now let's say just now the stinghorn fungus is very smelly because it's trying to attract flies. The flies will come and then they will be walking all over the mushroom. Then the top part is the part that produces the spores. Then the spores will stick to the flies' legs and body and everything, and then the flies will fly off, and then the spores will get spread. Will get to spread. Yeah.
The
So
animal becomes the savior of both the plant and the fungi.
sorry.
The animals become the savior for both the plants as well as the fungi group.
At different state, yeah. At different state, yes.
Actually, for insects, I'm going to chip in here.
Sure.
There are few families of beetles. They have a little pouch that they carry spores. They're symbiotic fungi. So like bark beetles, when you eat under the bark, right, they'll make those nice galleries under they chew the bark. They actually carry spores, so they'll go and seed those spores and everything. They'll grow into those networks and everything, and they harvest the fungi. And then stag beetles also. Stag beetles, they have when they come out, when the females emerge from their as adults, right, they actually evert part of their anus or something, so it's a little pouch and they scoop up the symbiotic yeast that they had as a grub. So they will then use that to make sure the next generation has the fungi or the yeast to break down the food. So it's very, very important for them. What else? The black termite that we have in Singapore that bites you very big. That's Macrodermis carbonarius. They found fungi. So inside there, you see the termite mound, right? Inside you break it open, don't break it open. There is a fungal comb. So it's like a little very beautiful comb inside. They harvest, they feed on fungi. And what's very cool is that these species of Termitomyces, right?
Yeah.
They're actually edible.
Yeah.
It's not, but most of them are edible, right?
No, they are all edible.
Right? Because
All
in
edible.
In Africa, there's a giant one called Termitomyces titanicus or something.
Yeah,
like
yeah.
that. It's huge. It's a delicacy there. Yeah,
So it's something like the cow, because the cow's gut is actually very short. So you actually got a extra stomach where it takes some time to digest all the fibers and then put it back into the system again. But nothing to do with fungus and all that lah. So different animals got different. Body
No, there are fungus in there also.
Also there.
They are also in there.
So in the gut system itself, you see, the nature is modified in such that within one cycle, even though the cow cannot get the nutrients then they modify the system so that there is a regurgitation process going on inside the animal, and then
Yeah, so the cow actually passed the fungus to the calf. Yeah, a lot of the animals do that. Ants also can do that also. Yeah. So
there is expensive coffee in Indonesia, which actually the civet cat is the one which eat the fruits, and then the seed comes through the anus, and then they use the seed to make coffee. But the problem is this businessman, they want the civet cat to eat a lot so that and then they cage it and all that. So they go and convert the natural process into an artificial process. And then when the coffee which comes to the table, it's not as tasty as the original coffee which the civet cat actually started many, many years ago, Anyway, the coffee is very expensive.
yeah, please don't buy. It's supporting this very cruel practice. Yeah.
Absolutely. Yeah. Okay.
Yes.
Are there any structural differences between a terrestrial and aquatic mushroom?
No, they all start off with spores and then hyphae. The hyphae got difference. There are different kinds of hyphae. So for those like your lingzi and all that, right? When you feel the mushroom is very, very hard, right? Whereas you feel those like maybe those growing by the grass or some that now you see 2 hours later you don't see anymore. So those are very, very soft. So basically there are 3 different kinds of hyphae. Generative, then there's a skeletal, I forget there's another one. So 3 different kinds of hyphae that gives it different strength and how fast they auto-digest.
For the hyphae, the aquatic one, right? Like she was asking, how do they take in oxygen? Like, is that
Yeah, the water has a lot of dissolved oxygen.
so is that different? Does that affect the hyphae structure?
No, because it's the same. It's the same as when they did find it on terrestrial environment. Yeah.
Because it was the same one that was found in both, right?
Yes. Yeah. Mushroom can handle low oxygen environment.
How about the deep sea?
The deep sea, they can handle the low oxygen environment. So in the deep sea, there will be the microfungi, the other group. So they will not be producing a big mushroom body, but their hyphae will be around. It will be breaking down whatever marine organism. Sometimes you see the corals getting infected by a fungal disease. They found out that this particular fungus, there's a terrestrial counterpart. So, rain bring the fungus, go into the marine environment, then they infect the coral, the sea fan and all that. Yeah.
Okay. If there are no more questions, I realize we're running out of time. I'll thank Amy. So maybe we can thank Amy for her time. Thanks so much.
Thank you for coming.
That was very insightful, and I think we learned a lot about this particular topic. And I think there are some books that she brought. You want to?
Okay, so I'm helping La Roca to sell these books. So when you see the QR code, is basically this person bought all these books in bulk, and then he want to sell them lah. So basically these books are written, it's the same book, it's written by a number of Southeast Asian authors, and they appreciate biodiversity as God's creation. So that's why the title is called God's Gardeners. So if you like biodiversity, you can see how our action can contribute in a positive or a negative manner. You're welcome to browse, and then if you decide, you can buy. Each book costs $20. Yeah, it's not coming to me.
So that's the books on the table. Okay, so next up, as I close, Next up, we have Wild Conversations, the last one that's happening for the year. It's going to be on the 5th of December. So it's happening in 2 weeks, actually. 2 weeks, yeah. 5th of December, so that everyone can go for Christmas break. 7 to 9 p.m. It will also be here. We will be speaking, we'll be bringing you on an Amazon adventure. So we will be speaking with Associate Professor Adrian Liu from NUS Center for Nature-Based Climate Solutions to discuss about his recent trip to the Amazon for the X Prize Rainforest Competition, where he'll share about the different game-changing technologies that has been revolutionizing the conservation landscape. We will also have with us naturalist and professional photographer Ryan Peters, who photographed many famous people like Barack Obama and actress Fan Bingbing recently, and he was also in the Amazon very recently documenting the work of a conservation organization. So yeah, join us then to wrap up the whole year. That will be the last conversation for this year. So yeah, and don't forget to follow us on social media. We are at _wildspace on Instagram. And in the meantime, stay wacky, wild and curious. So thank you all for coming. Oh, one more thing. Actually, we do have, more mushroom stuff, but actually not. We do have a trip to Kenya happening next year. It is here. We are having an online briefing about this trip on the 29th of November. It is online. So if you're keen, you can scan the QR code or look at it on our website, wildspace.sg. We will be going in 2025 in the third quarter of the year. So yeah, if you're interested to find out more, you can join us for the briefing next Friday. It's online. Yeah. Thank you. Yeah. Okay.